Lesson 12.2 is equations of tangent and normal lines. So last section we talked about what a tangent line is. It's a line that touches but not crosses a curve at a specific point. So down here, this curve here, we have this blue line that is tangent to the curve at point A. The slope or the gradient of the tangent line is the derivative of the curve at that point. So the instantaneous rate of change of the curve is the same as the instantaneous rate of change or the gradient of the tangent line. So your slope is equal to f prime of c, where c is the x-coordinate of that point on the curve. A normal line is a line that is perpendicular to the tangent line. So if we have a circle here, for example, that has a tangent, then normal would be perpendicular through that same point of the tangent line. A little reminder, equation of a line is y minus your y-coordinate equals your slope times x minus your x-coordinate for your point slope form. And perpendicular lines have opposite reciprocal slopes. So just flip them over, change the sign. So given this, if you have a point where you want to find the tangent line at x equals c, then the equation of the tangent line would be y minus the y-coordinate, which would be f of c, is equal to the slope, which would be f prime of c, times x minus your x-coordinate, which would be c. The sides of a hill can be modeled by the function f of x equals negative 0.02x squared plus 3.4x for certain values of x. So for part A, we want to sketch the graph of f of x. Then there's a monastery that's built at the top of the hill, which could be an interesting tourist attraction. So it's decided to build a funicular railway to reach the top of the hill. The railway can be modeled by the tangent to the curve where x is equal to 50. So for part B, we then want to find the derivative of f of x. So go ahead and pause the video and try parts A and B. So here's my graph over here. It has a 0 at 0 and a 0 at 170, and that has a maximum. And so this is our hill. And then I found the derivative, bring the power down in front, reduce the power by 1. So you end up with f prime of x to be negative 0.04x plus 3.4. So this is the derivative. It's also the instantaneous rate of change of the graph, and it's also the gradient of the tangent line at any point x. So using the fact that this represents the gradient of the tangent line at any point x, part C says find the gradient of the tangent at the point where x is equal to 50. And then part D, find f of 50, and then find the equation of the tangent line at x equals 50. So go ahead and pause the video and finish the problem. So given that the derivative is f prime of x is negative 0.04x plus 3.4, I found f prime of 50, and I got 1.4. So this would be the slope of the tangent line, or the gradient of the tangent line. And then we also need the y-coordinate of the original function at x equals 50. So I plugged in 50 to the original function, and I got 120. So then using point slope form, y minus my y-coordinate of 120 equals my slope of 1.4 times x minus the x-coordinate of 50. You can either leave it that way, or I simplified it into slope-intercept form and got y equals 1.4x plus 50. So then here is our tangent line. And the only place that it touches in this small area is at 50, 120, and it has a slope of 1.4. This next example says to find the equation of the normal line to the curve with the equation f of x equals 2x squared plus 3x minus 2 at the point x equals 1. So remember, normal lines are perpendicular to tangent lines through that same point. So go ahead and pause the video, find the derivative, find the slope of the tangent line at x equals 1, and then see if you can find the equation of the normal line from there. So first I found the derivative. The derivative of 2x squared plus 3x minus 2 would be f prime of x is 4x plus 3. And then I plugged in x equals 1 and got 7. So this would be the slope of the tangent line. And then tangent lines and normal lines are perpendicular to each other. So to find the slope of the normal line, I would take the reciprocal or the opposite reciprocal, and I get negative 1 over 7. So if you haven't already done so, go ahead and pause the video and finish writing the equation of the normal line. So you need the y-coordinate in order to do point slope form. So I found the y-coordinate of the original function by plugging in 1 into f of x and got the y-coordinate to be 3. And so using point slope form, y minus your y-coordinate of 3 is equal to your slope, which we found to be negative 1 over 7, times x minus your x-coordinate of 1. And either leave it that way, or if you write it in slope-intercept form, it'd be y equals negative 1 over 7x plus 22 over 7. So here's 3 more functions, and we want to find the equations of the tangent and normal lines for all 3 functions at the point x equals 3. So go ahead and pause the video and try number 3. So for part A, f of x equals 2x squared plus 3x minus 5. So I found the derivative f prime of x, but it actually ends up being the same as the derivative for number 2, 4x plus 3. So to then find the slope of the tangent line, I want it at x equals 3, so I'm going to plug in 3 for the derivative, and I end up with f prime of 3, or my slope of my tangent line, to be 15. And so if the slope of my tangent line is 15, that means the slope of the normal line is the perpendicular slope, opposite reciprocal, so that's going to be negative 1 over 15. For both of these, I need the y-coordinate at that point x equals 3 in order to write my equation of the line. So I found f of 3 to find the y-coordinate, and I end up with 22. So the tangent line is y minus 22 equals 15x minus 3. The normal line is y minus 22 equals negative 1 over 15x minus 3. Notice the x1, y1 don't change because they're still both going through this point at x equals 3. So if you haven't already done so, go ahead and pause the video and finish B and C. So for part B, I found the derivative of x to be 3x squared plus 2. So then the slope of the tangent line would be f prime of 3, which ends up being 29. And the slope of the normal line would be the opposite reciprocal of the perpendicular slope, so negative 1 over 29. I also needed the y-coordinate at x equals 3, so I found f of 3 to find the y-coordinate, and got 3 cubed plus 2 times 3 plus 1, which is 34. So then your tangent line is y minus 34 is equal to 29x minus 3, and your normal line is y minus 34 equals negative 1 over 29x minus 3. And then the last one, f of x equals 2 over x plus 1, which is the same thing as 2 times x to the negative 1 plus x. So the derivative f prime of x would be negative 2x to the negative 2 plus 1, or negative 2 over x squared plus 1. So then the slope of your tangent line at x equals 3 would be f prime of 3, which would be 7 over 9. And the slope of the normal line would be its perpendicular slope, or its opposite reciprocal, so negative 9 over 7. And then I need the y-coordinate at 3, so I found f of 3 to be 11 over 3. So the equation of the normal line is y minus 11 over 3 equals 7 over 9 x minus 3. And the normal line is y minus 11 over 3 equals negative 9 over 7 x minus 3. So equation of tangent lines, your slope is the derivative at that specific point. Then you need to find x and f of x at that point, just use point slope form. And then normal lines are perpendicular to tangent lines, so once you have the slope of the tangent line, the normal line is the opposite reciprocal. So this next example, they say that the gradient of the normal line to the curve with the equation f of x equals kx cubed minus 2x plus 1 at the point 1 comma b is negative 1/4. And we want to find the values of k and b. So they give us the gradient of the normal line, and they give us a specific coordinate. So go ahead and pause the video and see if you can figure out what k and b are. So the first thing I did was I took the derivative of f of x equals kx cubed minus 2x plus 1. Whenever you see normal, tangent, gradient, curve, anything like that, usually when in doubt, take a derivative. So I took the derivative, and the k is just a constant, it's like a 2. So I brought the power down in front, reduced the power by 1, you end up with 3kx squared minus 2. So then I knew if I need to find, or they give us the gradient of the normal line to be negative 1/4, that tells me that the slope of the tangent line would be its opposite reciprocal of 4. So the slope of the tangent line at x equals 1 is 4. So I plugged in x equals 1 to my derivative, and I got 3k minus 2. So this has to be equal to 4, because that's what I know the slope of my tangent line is. So then 3k minus 2 is equal to 4, so I solved for k and got k to be 2. So now I know k is 2, and I want to find the y-coordinate at x equals 1. So I just plugged in x equals 1, 2 times 1 cubed minus 2 times 1 plus 1, and that has to equal b because that's the y-coordinate, and so b ends up being 1. Lastly, we can use our graphing calculator to find derivatives for functions that are above and beyond the power rule. And so if you go to math on your graphing calculator, number 8 is in deriv. And if you have a newer calculator, it'll show up and look like this. So it'll have d over d with a box, and then a parentheses with a box, and then a solid box equal to a not solid box. This first solid box, or not solid box, should be x, their variable x. Inside should be the function, whatever you're looking at. It will autofill whatever you type in here, it will autofill in here. So then this last box is just wherever you want to take the derivative at. So for example, if we want to find the derivative of the function y equals x plus 2 over x minus 1 at x equals 2, I'd go math 8, which is in deriv. I'd have d over dx is equal to x plus 2 over x minus 1, or of x plus 2 over x minus 1, and then x equals 2. So go ahead and plug this in your calculator and see what you get. So if you plug that in your calculator, you should end up with negative 3. Your calculator will give you negative 3.000003, but it's the way that it does it. The derivative is actually negative 3. So go ahead and pause the video and try the derivative at x equals 3. So if you do the same thing, you end up with negative 0.75. So to find a derivative on your calculator, you go to math, number 8 in deriv, fill in your information, and then it'll give you your derivative. There's actually another way you can do it as well. If you already have something that's graphed, you've graphed the function under y equals, if you go to second trace number 6, that's dy dx, and then you just type in your x value and it will give you your derivative in there as well. So this is helpful if you've already have the function graphed. So this has been the equations of tangent and normal lines.